that are now sort of routinely used to make these bilayer constructs. So essentially, the general description of these molecules, or the theme, is to have a lipid-like moiety, again, synthetically tethered to a linker, in this case ethylene oxide, which again, various lengths. These were essentially empirically determined as to what lengths to make in terms of getting these tethers away from the gold surface, and then using double-branched lipids, and in one case it's in 2 cases saturated lipids, and then in one case a single one double bond lipid. So again, we want to mimic membranes on solid surfaces. The idea of sparse tethering is to get that bilayer away from the surface and it floats, and a lot of effort has actually been placed on reconstitution with as few tethers as possible to have stable bilayers, but to allow the natural fluidity of the membrane. So one of the things that is in process right now to tell you about is the second generation of tethers. And so again, the idea is if you have, one of the thoughts now is most of those original tethers were single sulfur linkages to the gold. And so the second generation of tethers are based on the idea of using 2 sulfur links to the surface. So basically having two sulfur linkages here, and in some cases a multi-connected sulfur linkage to the surface, again to stabilize and also create, in this case, a separation through a branched ethylene oxide molecule. The idea, again, is to create, again, more stable linkages here so that one can use fewer tethers. That's sort of still ongoing. So just to give you a quick cartoon of how this works,